What other potential areas can we look at for pragmatically convincing counterexamples to the claim that every invalid argument form has a precise counterexample? And recall, the reason we're on the hunt for those is I'm claiming that they don't exist, and it's key to my argument that they don't exist. Pragmatically convincing counterexamples to the claim that every invalid argument form has a precise counterexample. Okay. So in other words, we're looking for invalid argument forms which lack precise counterexamples. And pragmatically convincing means that the invalid argument form, following it will lead you into some kind of practical error in some case, right? Okay. So in this section, we're going to look at Intuitionism. And Intuitionism is a school of thought founded by the mathematician and philosopher L.E.J. Brouwer. Intuitionists claim that classical logic is wrong. And so we're going to look at what they have to say. So here is my summary of some core theses or assumptions of Intuitionism. I don't assume that all Intuitionists would agree with all of these statements, but they represent my best attempt to represent the views of Intuitionists in general and simple terms. I have weakened phrasing that my sources use in some places, particularly by removing the term know/knowledge, in order to assist the presentation going forward. 1. Immanuel Kant, in the Critique of Pure Reason, was correct in arguing that there are synthetic a priori truths. A priori truths are truths which we can discern by introspection alone, without engaging in empirical investigation. Synthetic, as opposed to analytic truths, are truths that are not true merely by virtue of the definitions of the words they contain, but rather are true by virtue both of the definitions of the words they contain and by virtue of facts about the world. Synthetic a priori truths, then, are truths about the world which we can discern by introspection alone, without engaging in empirical investigation. And so Kant is correct in arguing that there are synthetic a priori truths, according to Intuitionists. So Intuitionists believe in synthetic a priori truths. So 2, next Intuitionist belief. Mathematical statements are synthetic a priori truths. One verifies mathematical statements by means of constructing mathematical objects in one's mind and observing their properties. And 3, the rules of classical logic are not correct in all cases in the context of math. The rules of logic that are correct in the context of math are the rules of intuitionistic logic. All of the argument forms that are valid according to intuitionistic logic are valid according to classical logic. The converse is not true. Some argument forms that are valid according to classical logic are invalid according to intuitionistic logic. If intuitionism, as represented by these 3 statements, is correct, then evidently the rules of classical logic are not correct in all contexts. And just to clarify, I don't know how well these three statements represent the views of any particular intuitionist. This is just my best attempt to represent intuitionist views and generalities in a form that will be convenient for the argument I want to make. Just the form. Not I haven't this is a good faith attempt to represent the views of intuitionists, right? Okay. So and now here is my personal opinion on intuitionism. I don't lean on these opinions for making my argument, but this explanation is part of the setup of the argument, in the following way that I'm going to be So I agree with some of what intuitionists have to say, and I'm going to grant them those parts of what they're saying. All right. So I agree with statement one. Statement one, right? There are synthetic a priori truths. And I also agree with statement two, which is that mathematical statements are synthetic a priori truths. And that one verifies mathematical statements by means of, but here's where I depart from intuitionists, right? Intuitionists say that we verify mathematical statements by constructing mathematical objects in our minds and observing their properties. I say we verify mathematical statements by means of observing mathematical objects in our minds. So I've replaced the word constructing with the word observing, a replacement which substantially modifies the meaning of the statement. So I'm a Platonist about math. I believe that mathematical objects exist in an infinite, timeless realm of heavenly forms, and that humans can discern mathematical truths by observing mathematical objects. I will go into this topic more in the section titled Math, and my present argument does not in any way depend on the assumption that mathematical Platonism is true. However, I do make use of the concept of mathematical Platonism in making the mechanics of the argument run. So for our purposes, the key question is whether intuitionists can make a pragmatically convincing case for their position. According to intuitionists, some mathematical statements are neither true nor false because they can neither be verified nor falsified by means of correct math. Since the statement A or not A expresses that A is either true or false, according to intuitionists, following the rules of classical logic will sometimes lead one from truth to untruth. The key question for us is whether their case can be made pragmatically convincing. It is informative to consider my difference with intuitionists on the topic of whether we construct mathematical objects in our minds as opposed to merely observing them in our minds. Does this difference of philosophical opinion have any pragmatic significance? Does it matter in any practical case which of our opinions is correct, mine or the intuitionists, if either of them? Only if there is some practical application of math where classical math brings us to conclusions that are untrue in a way that is significant and bad for some practical purpose, and where intuitionistic math does not lead us into the same untruth. Having looked for such a case, I'm not aware of such a case. Going forward in the argument, I assume there is no such case, but please inform me if you think of one. It follows from this assumption that pragmatically it does not matter whether statement 2, mathematical statements are synthetic a priori truths, is true or false. Doesn't matter. So one verifies mathematical statements by means of constructing mathematical objects in one's mind and observing their properties. So one way statement. Sorry, that was part of statement 2 that I just read out. Got a little mixed up there. So one way statement 2 can be false is if mathematical Platonism is true, so that mathematical objects are not constructed by humans, but merely observed by humans. Since it doesn't matter pragmatically whether Intuitionism or mathematical Platonism is true, it doesn't matter pragmatically whether it's true or false that mathematical statements are synthetic a priori truths. Okay, so if mathematical Platonism is true, then most would agree that it is coherent for statement 3 to be false. To recall, statement 3 is the following. Not all rules of classical logic are correct in the context of math. The rules of logic that are correct in the context of math are the rules of intuitionistic logic. I think most philosophical logicians would agree that it is coherent and logically possible for mathematical Platonism to be true, and for all mathematical predicates to be precise, and that this would imply that all the rules of classical logic are valid for math, in the sense that the rules of classical logic would not allow inferences from true mathematical premises to false mathematical conclusions. Henceforth, I will assume that it is coherent for mathematical Platonism to be true and statement 3 to be false. And statement 3 is the one we care about, right? It's the statement that classical logic is not correct for math, intuitionistic logic is correct for math, is statement 3. So I just argued it is coherent for mathematical Platonism to be true and statement 3 to be false. And it follows from that if mathematical Platonism is true, then statement 2 is false, and it's coherent for mathematical Platonism to be true and for statement 3 to be false. So statement 2 was statements of math are synthetic a priori truths that we verify by constructing math objects in our minds. So now here's the problem for the intuitionist. Right? If mathematical Platonism is true, then statement 2 is false, because we don't construct mathematical objects. Rather, mathematical objects are out there, and we observe them with our minds, right? So we don't construct them, so statement 2 is false if mathematical Platonism is true. And, right, I've just argued it's coherent for mathematical Platonism to be true and statement 3 to be false. So according to what I've so far said, it is coherent for mathematical Platonism to be true. And it follows that it is coherent for statements 2 and 3 both to be false. Additionally, as far as I can see, there is no practical application of math where it is pragmatically significant whether statements 2 and 3 are both true, as intuitionists hold, or whether they are both false. I will assume the preceding sentence going forward, but please inform me of any counterexamples you find. So from what has been said, it follows that it does not matter pragmatically whether or not intuitionists are correct in saying that the rules of classical logic are not valid in all cases in the field of math, this being part of the content of statement 3. In other words, it follows from what has been assumed that intuitionists have no pragmatically convincing counterexamples to the claim that every invalid argument form has a precise counterexample. So that completes my pragmatic defense against the intuitionist attack on classical logic. This defense is pragmatic indeed for our purposes, in that it means we have not encountered a need to learn/teach another system of logic, such as intuitionistic logic, in addition to classical logic, which we already talked about.